Okay, in the last video I showed you how to determine the end behavior of a polynomial function, and I showed you how to uh, essentially tell how many times it changed directions, which is by its exponent. So now I'm going to show you how we're going to graph it with this example right here. Now this is positive and this is an odd exponent, so I know that it's going to start at negative infinity and it's going to end at positive infinity. So it's going to change directions 3 times. It's going to be going up, change 1, 2, and end over here 3. But I don't know exactly where this is going to be on a graph. So the way that I'm going to do that is by finding the zeros. So on this one, I can't factor by grouping. That's not going to work. But what I can do is I can use the possible rational real zeros, which are plus and minus 1, plus and minus 2, plus and minus 4, and plus and minus 8. All the factors of this divided by all the factors of this. Since it's just over 1, I'm not going to put it over 1. That means the same thing. So now I'm going to try that. I'm going to use synthetic division to see which ones work. And this can take a while sometimes. Remember, I always like to start with the low numbers just because it's easier. So 1 didn't work. I'm going to try negative 1. And negative 1 does work because it doesn't give me a remainder. So one of the roots is negative 1, which means one of the factors is x minus negative 1 or x plus 1. That's one of the factors. The other factor is what's left down here. So I started at x to the third. That means that this is going to be x squared plus 2x minus 8. Now I could continue with the possible rational real zeros, but I don't have to do that because this is a quadratic. So quadratic, I can either factor it in my head or I can use the quadratic formula. This one I'm going to factor in my head. I need two numbers that multiply to negative 8 and add to positive 2, which is plus 4 and minus 2. So these are my three roots. These are my three factors, which means my three roots are negative 1, negative 4, and 2, which I get from just setting each of these individual things equal to 0. I'm going to do that on my graph now. So x is negative 1, that's a 0. X is negative 4, that's a 0. X is 2, that's a 0. Now I know that it has to start at negative infinity, so I know that this one's going to come from this direction. How steep it comes, I don't know, and that's not going to be really important because we're not going to be able to tell that, okay? So I just want you to do the best that you can. This one is going to continue on to infinity, so it's going to go that way. So I already know those two parts. What I also know is that a vertex, if you remember on our quadratics, when we did quadratics, the vertex is exactly in the middle of your two zeros. The same thing is going to be true here. So I'm going to have a vertex that's exactly in the middle of this. The x value of the vertex from negative 1 and 2 is I add those two together and divide by 2. So negative 1 plus 2 is 1, divided by 2 is 1/2. So the vertex of this is going to be at 1/2, which is exactly in the middle, 1.5, 1.5. I take the x value and I plug it into the equation. So this is going to give me a point. I'm going to take the x value and plug it into the original equation way up here. So 1/2 cubed plus 3 times 1/2 squared minus 6 times 1/2 minus 8. This is going to be 1/8 plus 3/4 minus 3 minus 8. This is going to be 6/8, so 7/8 minus 3 minus 8, which is going to be, oh man, that's negative 11. Negative 81/8, which is just over negative 10. So really, negative 10 and 1/8. I know that you're not allowed to use mixed numbers, but that's what we're looking at. So I'm going to go down to negative 10. and go just past it for 1/8. That means that the vertex has to be right here. So these guys are going to connect to this spot just like that. Now I'm going to do the same thing in between these two. The vertex has to be halfway in between -4 and -1. So I'm going to add those together, which gives me -5 divided by 2. I'm going to plug that back into the original equation. -5 over 2 cubed plus 3 times -5 over 2 squared minus 6 times -5 over 2 minus 8. This is going to give me -125 over 8. This is going to give me plus 75 over 4. This is going to give me plus 30 over 2, which is 15, and then minus 8. When I combine this all together, that's going to be 150 over 8, which is going to be 25 over 8, plus 15, minus 8. That's going to be over 8. 81 over 8. Oh, the same number, just positive. So I'm going to go up to 10. Go just past it, 10 and 1/8. Put a dot, and then I'm going to connect these two guys. And that's it. We're done graphing this one. So we can't tell the exact steepness of these lines, but we can tell where it changes directions. Now I asked you to figure out the local minimum and the local maximum. The local minimum and the local maximum are your minimum and maximum values that you can see on the graph. So the maximum value that you can see on the graph is this point right here. This would be the local maximum. The local maximum is the value, the y value right here. The y value right here is 81 over 8. The local minimum is the minimum value you can see on the graph. So this point right here. So the local minimum is -81 over 8. These won't always be the same number. It just happened that they were the same number, and one positive, one negative on this one. Okay? I'll do one more, and then that should hopefully be enough. Let's see.